Okay, so 11.5 is a section that definitely will come up in Calculus 2. You're going to be asked in Calculus 2 to integrate. So in pre-calculus, we teach you how to take rational functions and decompose them into what they came from. And we call these partial fractions. So in this section, we will learn a way to decompose rational expressions. There are four main cases that we worry about in this class and in Calculus 2. And in fact, case 4 is actually a pretty, it doesn't happen as often, but we're going to do it just in case. So this section is pretty straightforward. It's just a way to break down a fraction into into its components. And that's what the decomposition does. So a lot of times, if you have me for Calculus 2, I'll call this PFD, partial fraction decomposition, okay? So the first case is we have a rational expression and we're going where Q has only non-repeated linear factors. So what that means is our denominator is factored and it's in linear, and there's only linear factors and none of them are repeated. So in this case, the factors of the denominator are x and x minus 2. Both individual, non-repeated linear factors, okay? So what you do, this is how you set it up, is you set up 2, let me write this a little bit cleaner, 2 over x times x minus 2, and if it's ever not factored in the denominator, then you have to factor it. Sometimes they hand it to you pre-factored, sometimes you have to factor it yourself. And what you do is you take and set a constant over x, plus another constant over the other factor, x minus 2. So these are our partial fractions right here, okay? And we're trying to discover what constant we need to put in the numerators. So what we do is we multiply both sides by the LCD, and the LCD would be x times x minus 2, and this would be x times x minus 2 over 1, right? Over 1. So we know that this distributes simultaneously. This cancels with this, and we're going to be left with 2 equals, and then we're going to have a times x minus 2 because the x's cancel, right? And then here the x minus 2's cancel and it resets, and we'll be left with bx. Okay, so we have this situation. Now we have an equation, but the problem is we don't know a, we don't know b, and we don't know x. So for this easier version of the problem, what we're going to do is, this is an equation, right? And our job is to solve for a and to solve for b. So I'm going to pick an x that will eliminate one of the b's, okay? Or I'm sorry, one of the variables, x or, I'm sorry, a or b. So I'm going to say let x equal, maybe I'll do this in red because this is kind of like my scratch work. Let x equal -2, or I'm sorry, not -2, +2. Right? So this is my x's. You want to pick a good choice for x. So now I'm going to plug x into this equation. So now I have 2 is equal. Now when I plug that into here, this will become 0 plus 2 times b, right? Or b times 2. So then I divide. So this will be 2 equals 2b. So then b is equal to 1. So I have my b, right? I have this b right there now. Now I go to do the next one. I'm going to say, what's another good choice for x? Use a smart choice for x. Remember, x could be anything, but there's particular values that will be very helpful. If we let x be 0, then we're going to have 2 equals -2a, right? Because 0 minus 2 is -2. And then this would be plus b times 0, right? So then we're going to get a is equal to -1. Okay, so now I can come over here and I can say that a, so 2 over x times x minus 2 is the same as -1 over x plus 1 over x minus 2. And this would be my partial fraction decomposition. That's all you do. That's it. So normally what you do is you want to choose the x's that really help you clean up the equation much faster. Okay, so case 1 is really nice. We'll try to do another one at the very end for a little bit of practice. Now, case 2 is a little bit different. Case 2 says for P over Q, Q has repeated linear factors. So as you can see right here, this is x minus 2. So x minus 2 occurs twice because it's x minus 2 times another x minus 2. So when you do that, when you account for this as partial fraction decomposition, you have to do a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared. You have to account for every power of the repeated factor. So we had x minus 2 squared, so we had to do x minus 2 to the first, x minus 2 to the second. If this was, for example, x minus 2 to the cube, we would have had to do d over x minus 2 cubed. We would have needed to account for every single counting power. So we would have had to go first power, second power, third power. But since it's only x minus 2 squared, we're able to just do like this. So now we need to multiply by the LCD, and the LCD is going to be x plus 1. I'll write it like this. X plus 1 over x minus 2 quantity squared, and then this will be x plus 1 over x minus 2 quantity squared. All right, so this will cancel. That side will always cancel, so that'll be, at least that's a nice part about this. So we have x squared equals, now we have to distribute all of this to each one. And remember, each time it cancels, it resets when you distribute again. So the x plus 1s cancel, and I'm left with a times x minus 2 quantity squared plus b times x plus 1. One of the x minus 2's cancel, and I'm left with just one x minus 2 plus c times x plus 1, because both of the x plus 2's cancel. So now we're going to say let x equal. Now, what is a good choice for x in this particular problem? What do you guys think? So you got to, think about this. Let's say that x was equal to 17. Would that work? Sure, it would work, but it wouldn't really take care of a lot of things for me. I'm going to pick 2 because that's what would make this guy 0. So I'll be able to wipe out the a. So for x equals 2, I'm going to say that 2 squared is 4 equals 0 plus 0 plus 3c, right? Because 2 plus 1 is 3. If I'm over here and I'm plugging in 2, I get 2 plus 1 is 3 times c. So then I divide both sides by 3, and I get 4/3 is equal to c, okay? Now, what's another good choice for x? Let's see here. Let x equal -1, right? If I let x equal -1, when I do that, this will become 1. So -1 squared is 1. This will become, this one right here will become -1 minus 2 would be -3 squared would be 9a. Now this will become plus 0b's, and this will become plus 0c's, right? So then we just have 1 over 9 is equal to a, right? So I got that one now. Now here's the problem. We used up all of our good choices. All of our good x's are already gone. We don't have any other good ones. So then what you should do is pick another x that you can do calculations with very quickly. So what I'm going to do is I'm going to say let x equal 1. Now this won't clean everything up, but you'll see what happens. If I let x equal 1, then this will be 1 squared, which is 1. And then if I plug 1 into here, this will become 1 minus 2 is -1. -1 squared becomes a. If I plug 1 into here, this becomes 1 plus 1 is 2 times -1 would be -2. So this will be minus 2b. And then if I plug 1 in here, I get plus 2c. Now that might look terrible, but we actually know a and c. So we're going to say that this is a is 1/9 minus 2b, and then c is plus 4/3. Let me just double check something real quick. This is number 1c. I feel like I might have made a mistake here somewhere. So we got x squared. I got a over x plus 1, b over x minus 2, and c over x minus 2 squared. Yeah, I think that's it. It's the answer sheet is telling me otherwise. 1, 3, 3, 1. Oh no, never mind. I'm sorry. Oh no, these are correct. I'm sorry. I thought I was reading the wrong answer sheet. Okay, so far so good. Now what we're gonna do is we're now gonna use our calculator, and we're gonna do 1 minus 1 divided by 9 minus 4 divided by 3. So I subtract it over. I do math frac, oops. 1 minus 1 divided by 9 minus 4 divided by 3. Math frac. So I get negative 4 over 9 is equal to negative 2b. So now I'm going to divide this or multiply by negative 1/2. So now b equals 2/9. Right, because this cancels with this and we get 2/9. Okay, so now when I go to write my partial fraction decomposition, I now get to say a over x plus 1, but my a is 1/9, so this will be 1/9 over x plus 1. You know what, I'll write this a little bit better for you guys. 1/9 over x plus 1. Okay, and then b is 2/9, so it'll be plus 2 over 9 times x minus 2 plus c, which would be 4 over 3 over x minus 2 quantity squared. Now, in reality, you can actually clean this up even more. I'm not sure how the homework wants it, but you guys could write it like this: 1 over 9 times x plus 1 plus 2 over 9 times x minus 2 plus 4 over 3 times x minus 2 quantity squared. It really depends on how they want the answers. They may take the top one, but I'm just going to give you both. In calculus, what we're then going to do is we're going to integrate each one of these piece by piece. But for now, we'll just learn how to do partial fraction decomposition. So we have found each one of the partial fractions, and we found the constants that make them work. Okay. So that's how you do that. Now let's go to this one, case 3. Now this is about probably one of the harder ones I'd ask you from the exam for the exam. I don't think I'll ask you a case 4, but maybe. But case 1, 2, or 3 are fair game. Case 4 is a maybe. So it says for P over Q, Q contains a non-repeated irreducible quadratic. And all irreducible means is that it can't be factored any further. So it's a quadratic, but it can't be factored besides using, like, square roots or something like that. It can't be factored in a nice fashion using rational numbers, okay? So what we have to do is, this is not factored. So I first have to factor this. This is 3x minus 5 all over. Now this is the difference of cubes. So this would be x minus 1 times x squared plus x plus 1. So I just factored, and that's the difference of cubes. That's just a formula. If you guys don't remember that, you got just look it up online or something like that. That's the difference of cube formula. You can figure that out. So I just did the factors. Now I have to write this as a over x minus 1. Now here's the thing, when you're doing a quadratic, it's an x squared factor. So we have to step up our game on the top, and the numerator will become bx plus c. Instead of just plain old b, it's bx plus c. So it's a linear factor in the numerator divided by a quadratic factor in the denominator. So then we have x squared plus x plus 1, which is irreducible, okay? So now the job is the same as before. We're gonna multiply both sides by the LCD, which is x minus 1 times x squared plus x plus 1. And then the same over here. You know what, I'll just put it up top. X minus 1 times x squared plus x plus 1, okay? Let's see here. So then this will become 3x minus 5, right? Because this will cancel with this. And now this will become a times x squared plus x plus 1 plus bx plus c times x minus 1, right? Because this will cancel and this will cancel, and this will be the leftovers, okay? So what I want to show you guys is a different technique. There is another technique besides this. You see how here I'm using like good, clever uses of x? Well, sometimes it's maybe even a little bit better. Instead of doing that, there's another technique that one of my teachers taught me a long time ago. So instead of guessing values for x that maybe are clever and help you clean things up, what we do is we kind of think about what equality means. So what I'm going to do is I'm going to rewrite this. This is 3x minus 5 equals, and now this is going to be a x squared plus AX. I'm going to distribute the A, and I'm going to distribute this. So this is plus A plus BX squared minus BX plus CX minus C. So what I'm going to do now is I'm going to group everything that has an X squared and everything that has an X, and then everything that does not have variables or doesn't have an X at all. So when I regroup this, this becomes 3X minus 5. And now I'm going to say that this is A plus B times X squared. So look right here. I took this and I took this and I factored out an X squared. Now, if I distribute the X squared, will I get back to the top? Will I get back to AX squared plus BX squared? Yes, I will. So this is legal to do. It's okay to write that. Now I'm going to take a look at the X's, and I have an AX, I have a minus BX, and I have a plus CX. So this is going to be A minus B plus C times X, right? And then this is going to be plus A minus C. Okay, so all I did was I looked at this, this, and this, and I factored the X out and put it right there. I just put it in the behind the parenthesis. And then for this one, I just have an A and a C with no X's, so no factoring or anything like that necessary. So this is what I have. And you may think this is terrible, but what I can now do is I can build a matrix. So we have the X squared term right here, and it has a coefficient of A plus B. But remember, this is an equal sign. So that means there has to be an X squared term over here as well. However, there isn't one. So what does that mean the coefficient has to be? So if I'm going to have an X squared here that's not worth anything, then that means the coefficient in front of it had to be 0. So that means I can now say that A plus B equals 0. That's a fact I can say. Because the left-hand side of the equation does not have an X squared term, that means that this X squared right here has to cancel. And the only way that could happen is if A plus B was 0, so we could cancel out the X squared. Now we go on to the X term. Okay, so this is the X term over here. This is the X term over here. Well, this is plus 3X, and this is A minus B plus C equals X. So that A, or times X. So that A minus B plus C has to equal 3. So I'm going to write A minus B plus C has to equal 3. Now we come over here to the A minus C term, and we come over here to the minus 5. And we say A minus C has to be, negative 5. So we now have what we call in the previous sections a system of equations. So what I'm going to do is I'm going to build a matrix. And the reason I'm going to build a matrix is that way I can solve this very quickly. Now you could still try to use your clever X's to guess from the beginning, but I just wanted to show you this technique. Once you hit case 3 and 4, sometimes matrices help a little bit. And remember, we can use our calculator to very quickly find the solutions to a matrix or to a system of equations. So this will be 1, 1, 0, 0. It's an augmented matrix, remember that. This is 1, minus 1, 1, 3. This is 1, 0, minus 1, minus 5. Let me just make sure I wrote everything correctly. Yeah, it looks good. So now I'm going to RREF it. Okay, and let's see what we get. So I'm just going to do this on my calculator. I'm going to go second matrix. I can go faster if I just enter it in here. And this will be 1, 1, 0, 0, 1, negative 1, 1, 3, 1, 0, negative 1, negative 5. Then I'm going to math and go to RREF. Let me double check and see if I got the right ones. Let me just double check this real quick. Negative 213, negative 2/3, 2/3 plus 13. Yep, that's it. So when I plug this in my calculator, I get 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the other side is negative 2 over 3, 2 over 3, and I think 3 over 13. Oh no, 13 over 3. Sorry about that. Yep. Okay. So then that means I now have my A equals negative 2/3, my B equals 2/3, and my C equals 13/3. So that's why you learn matrices, so it can help you with stuff like that, okay? So now we got to come over here and we got to write our partial fraction decomposition. So we have A over x minus 1 plus bx plus c all over x squared plus x plus 1. So here we go. So A is worth negative 2/3 over x minus 1. Let me make this so equals negative 2/3 over x minus 1 plus bx. So this would be 2/3 x plus c, which is 13/3 all over x squared plus x plus 1. Okay, and if you wanted to clean this up, once again, I don't know how picky the book is going to be, but this would be 3 times x minus 1 like this, plus this would be 2x plus 13 all over 3 times x squared plus x plus 1. So I would believe that they would take both of these answers. Oops. But I just wanted to give you both. Okay, so I think this might be the answer they accept in the book, but just to be sure, I gave you the bottom one as well. Okay, so hopefully that makes sense to you. And this is a little bit of a harder one. And again, all I did with this is I compared the coefficients. So this coefficient had to match this coefficient. This coefficient in front of my x term had to match this coefficient. This coefficient had to, or this constant had to match the constant of negative 5. And again, the matrix thing is just, I guess we're just kind of showing off that we learned matrices, right? So we can use it. You could have still used let x equals this, let's x equal that, but you still probably would have ended up with a system of equations. Okay, so just so you know, it can be done the other way. I just wanted to take a minute to show you guys how to do that one. Okay, so now let's look at case 4. Case 4 is a little bit more difficult. It says, for P over Q, Q contains a repeated irreducible quadratic factor. So we have x squared plus 4, which cannot be factored, and it's repeated, okay? So what we have to do this time is we're gonna have to do ax plus b over x squared plus 4, just like before, right? But then we have to do it again for the second power, cx plus d over x squared plus 4 squared, right? So here's what we're going to do. Let's see here how this works. So we're going to multiply everything by x squared plus 4 squared over 1, and then this by x squared plus 4 squared over 1. Okay, so this will cancel with this, and we'll be left with x cubed plus x squared equals ax plus b times x squared plus 4, because one of them cancels but not both, plus cx plus d, but this time both of them cancel, right? So both of those cancel, and then one of these cancels. So let's see. I think we have to do it this way again. Yeah, because there's really nothing that's going to make that 0. I guess we could use x equals 0, but I think we should use this method that I used in the previous example. So we have x cubed plus x squared, and the coefficients are both 1. So we're kind of lucky on that. And then let's distribute. This becomes ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Now we're going to clean things up and group things together like I did in the previous problem. Well, there are no x cubes, it's by itself. There is no x squared, it's by itself. The x squared term is by itself. Now there is, however, an x term here and here. So what we're going to do is, so what we're going to do is we're going to say plus, I'm going to say 4a's plus a c times x would give us that back, plus 4b plus d. Okay, and now we have to set up our system. So x cubed, what's the coefficient in front of x cubed? It's a 1. So I'm going to say then that a has to equal 1. What's the coefficient in front of my x squared term? 1. Here's the b. So I'm going to say in front of the x squared term, b has to be 1. Okay. Now I know that 4a plus c, 4a plus c has to equal whatever's in front of the x term. Well, there is no x term over here, so it's got to be 0. And then 4b plus d, there is no just plain old constant over here, so it's got to be 0. So 4b plus d has to equal 0. So once again, I'm going to make my matrix, and this will be 1, 0, 0 equals 1. So 1a equals 1, 1b equals 1. And then, oh, do we have 4 equations? Oh, you know what? We don't even need to do this now that I look at it. Look right here. We know that a is worth 1, and here's an a right there. So what I could do is I could just say 4 times 1 plus c equals 0. So then c equals -4, right? Boom. I got c, I got a, I got b. What's the only thing left? I need d. So then we have d, 4 times b, but we know that b is 1, plus d has to equal 0. So then d is -4. Boom, we got d. So now we look up here and we have ax plus b. So this means that our partial fraction decomposition is going to be ax plus b. So that would be x plus b over x squared plus 4 plus cx plus d. So that would be c times x plus d, but d is -4, all over x squared plus 4 quantity squared. Okay, so we got that as well. So this would be my partial fraction decomposition for case 4. Okay, and that's all you do. That it's no big deal. It's not undoable. It's a very reasonable process. I showed you for the first 2, I just used good x's because in case 1 and case 2, picking good x's normally works better. And then in case 3 and case 4, sometimes picking good x's works. But normally you have to do something like this where you break it down into its coefficients. Okay, guys, I just wanted to kind of give you a brief background on partial fraction decomposition. We'll talk about some of this in the next class. That'll do it. Thanks for watching.